Welcome, students. This is Dr. Southard, and what I'm going to do here is I'm going to go over several problems from your homework quiz number 2, specifically problems 7, 8, 22, 23, 24, 27, and 30. And one reason I've chosen those problems is because it could be that you've never seen anything quite like these, and I just wanted to give you a little more insight. So let's work through these problems, and we're going to begin with question number 7. Let's look at the question. It says, based upon the following symbol, okay, what you're looking at here is a symbol. This is a nuclear symbol. It says, how many neutrons does the following carbon isotope possess? Now, there's some words there that I hope that you've read about. One of those is a neutron, and the neutron is a particle that's found in the nucleus of atoms, and it has a neutral charge, no charge. That's why it's called a neutron. And the other word is isotope. By now you've read that isotopes are species that have different mass numbers. Okay, so let's take a look at what's going on here. This serves as sort of a review for this portion of the chapter. First off, this number that you see is a superscript. Okay, this is known as the mass number. Right, it's called the mass number. And the mass number is the number of protons and neutrons combined. The number that you see here in the lower left-hand side is called the atomic number. Okay? Now, the atomic number is unique to each element. And as you already know, this is the elemental symbol. Right? We call this the elemental symbol. Now, you do not have to remember the names of elements from the periodic table, but it's kind of helpful to know those. So, if the mass number is the number of protons plus neutrons, in other words, P plus N, and the atomic number is simply the number of what? Protons, okay? Then all we have to do is subtract one number from the other to get the number of neutrons. All right? So let's just do that little math. 14 minus 6, that equals 8. And what does 8 equal? It's the number of protons. Okay? So this is carbon 14. It's an isotope, a minor isotope of carbon. Maybe you've heard of it. It's the one that they use for radioactive dating to figure out how old a fossil is or something to that effect. So if you've already done this problem and you figured out that the answer was 8, okay, congratulations to you. All right? So make sure that you understand this basic concept as it deals with isotopes. Okay? Let's move on now to question number 8 from your homework assignment number 2. I'm looking at question number 8. Let me get it centered here on the page. Now, what you might notice here is something that looks kind of like what we saw in question number 7, but there's something a little different. Let me read the question with you, and then we'll solve the problem. It says below is the symbol for the monatomic oxide anion. Okay? So look at those terms there. Monatomic means there's only one atom involved. Anion means that it has a charge, and specifically it has a negative charge. Let me highlight that. When you see the word anion, that means you're dealing with species that have negative charges. Okay? Negative charges. Now, when you think of the word negative, you typically put a negative sign in front of a number, like -1, -2, -3. But in chemistry, we put the number followed by the charge. Notice that? See, it's 2 minus versus -2, but you can think of it as the same way. Now, the word oxide simply means it's coming from oxygen. If it said sulfur, it would be sulfide. If it was from tellurium, it would be telluride, so on and so forth. Okay? Well, you already know what these numbers mean. This is the mass number, the number of protons and neutrons, and you already know that that's the atomic number, which is the number of protons. So we're going to be able to figure that out pretty quickly. But I'm going to have to show you how to go about figuring out the number of electrons, because it's going to be a little bit different than the previous problem. Let's go ahead and begin by recognizing that this is our mass number, right? 16, and this is our atomic number 8. So I think we can do that math again, all right? We have an 8 here. So let me just write down what we know so far. What is the number of protons here? Okay, well, you know it's that number, right? That number is constant. Every oxygen atom has 8 protons. That number never changes. How about the number of neutrons? Okay? The number of neutrons we just calculated as being 8. Got a lot of 8s going on here. So this was the oxide 16 anion. But the number of electrons is a little bit different. Okay? Now how do we do that? Well, the answer is certainly not 2. But what is it? Well, to be a neutral atom, you have to have the same number of electrons as you do what? Protons. However, we have 2 extra electrons here. So our answer is going to be what? It's going to be 10. Now, if you didn't understand what I just said, let me kind of show you another way to figure out the number of electrons, okay? Number of electrons. Let me just write that down. Number of electrons. Number of electrons. There's the whole phrase in there. Number of electrons. Okay? How could you do that? Well, what you can do is you can take the number of protons, okay? Number of protons, and subtract away minus the charge. All right? So in this case, what do we have? We have 8. We have 8 protons, and we're going to subtract away what? The charge. All right? Let me put an equal sign there to keep going. So what's 8 minus negative 2? It's the same as saying 8 plus 2. All right? So there's our answer. The number of electrons is equal to 10. Now, if you'd rather not memorize that equation, the simplest way to do it, okay, is simply look at the number of protons, all right, and then add whatever this number is to it. In other words, 8 plus 2 is 10. And it's going to be the opposite of that when we do cations, all right? So what answer down here corresponds to that? In other words, we need 8, 8, and 10. 8, 8, there it is. We have 8 protons, 8 neutrons, 10 electrons, all right? Now remember in your homework assignment, these are, when you work them on Canvas, these are scrambled, so make sure that you bubble in the proper one. So that's question number 8. Let's move on. I'm going to do problem number 22. We're going to leapfrog to 22, okay? Those other questions that you have in your homework assignment are pretty straightforward. You can get all the answers simply by reading through the book. All right. Question number 22. Let's take a look at that one. It says, which symbol below corresponds to a species possessing the following? Okay. All right. How does that work? Here's how we're going to do this. First off, you do have to have a periodic table to do this one. Okay. And so I provided you a periodic table on your Canvas site. You can download that. And it's really kind of helpful to have a color one. If you don't have a color printer, though, let me know and I'll mail you one. All right, I even wrote that in an announcement. But let's go ahead and solve this problem. The first thing you want to look at is the number of protons. Why? Because that's constant. And that never changes. Okay, so you have to look for a species with atomic number 20. Now, if you do that, you'll notice, right, there it is. There's our 20 in the upper left-hand corner. That's the atomic number. There's the symbol, Ca, and that happens to be calcium. So guess what? We have figured out, okay, we have figured out the identity of the element for that. So, again, this is going to correspond to calcium, all right? Now, the next thing we have to do, okay, is figure out how many electrons there are on the basis and how that affects the charge. It said we have 18 electrons, okay? What do you notice about that? What's weird about that? Well, it means we have 2 fewer electrons than we have protons, right? So if we have 2 fewer electrons than we have protons, then our charge is going to be 2 plus, right? It's going to be 2 plus. So that's how that works. Now, a simple way to do that is simply to take the number of protons, okay, and subtract away the number of electrons, right? So P minus E. What's the number of protons again? 20. What's the number of electrons? 18. What's the number here? 2 or 2 plus. So that's what we get with cations. So folks, this is known as the calcium cation. I'm bubbling in over here. You might notice that these aren't superscripted, okay? And the reason they aren't is because on Canvas you can't do that in the answer box. I don't like that, but we do the best we can here, okay? Okay. Now, before I move on, let me just kind of tell you something. You might see a pattern here. Where did you see calcium on the periodic table? Where was that? Wasn't it here? There it was. Notice the Roman numerals here, the 1A, the 2A, so on and so forth. Folks, everything in this column, particularly beginning with lithium, these are called the alkali metals, go all the way down. Guess what? They all have charges of positive 1 plus. If you go here to the alkaline earth metals in group 2A, right? These all have charges of 2 plus when they're ions. So you start to see a pattern develop, and you might notice that over time. Now, you don't have to memorize charges. I'm going to provide those for you, but this is an important aspect about chemistry. So over here, these are positive 1. These are positive 2. Now, hydrogen's a little weird. It can be positive 1. It can also be negative 1. So don't worry about hydrogen too much. Okay, that's number 22. Let's move on now to 23. 23 is kind of related to what we just spoke about in the previous problem, but it's a little different in that now we're going to have more electrons than we have protons. Okay? It says, what is the symbol and name for the ion with 7 protons and 10 electrons? So what's the first thing you're going to do? The first thing you're going to do, okay, is look at that. Why? Because the number of protons identifies the symbol, and you got to have a periodic table. So I'm going to come all the way over here. See that? That's 7 in the upper left-hand corner. That tells me this is nitrogen. Okay? It tells us that it's nitrogen. So we already know to write down the letter N. Now, the number of electrons, okay, is going to be evidenced by the superscript that you put here. Now, notice here we have 3 more electrons than we have protons. Now, what charge do protons have? Positive. What charge do electrons have? Negative. So we have 3 more electrons than we have protons, so therefore this is going to be 3 minus. Okay? And by the way, this is called the nitride anion. The nitride anion. So this works kind of like the previous problem, only now you have more electrons than you have protons. Now, another way to do that, okay, take the number of protons, okay, and simply subtract away the number of electrons. All right, so what's the number of protons? 7. What's the number of electrons? 10. What's 7 minus 10? Negative 3, or in this case, 3 minus. So that would be written as a superscript. So our answer is going to be this one. It's N3 minus, and it's called the nitride ion. Okay? Make sure you keep your eye on that charge. It's not 3 plus, it's 3 minus. Okay, this is called the nitride anion. Now, in keeping with what I spoke about just moments ago, folks, you start to see a pattern emerge as well over time. We're going to see that all of these over here have 0 charges. These tend to have negative 1 charges. These have negative 2, negative 3, okay? And right here, it starts to fall apart, you know, just can't really say that's negative 4, positive 4, anything like that. But for the most part, these are 0, negative 1, negative 2, negative 3, and so forth, okay? So that might be helpful, but again, you need not memorize charges on these monatomic anions, okay? So that's number 23. Let's go on now to number 24. Now, number 24 looks real simple, but it may require a little more effort on your behalf to figure this out. Now, this one's going to require some reading on your behalf in order for you to know. Okay. Now, I encourage you to actually figure out the answers to these things as opposed to just putting a Google search, so on and so forth. But it says, which of the following is a representation of sodium oxide? Okay, sodium oxide. Now, sodium oxide is an ionic compound. That means it's composed of ions. And one way you would know that is by virtue of the fact of where the elements are involved. The elements are very far apart on the periodic table, so therefore it's going to be an ionic compound. Sodium is found way over here on the left. Oxygen is found way over here on the right. That's what you get with ionic compounds. These are species composed of anions plus cations. Now, that being said, let me go ahead and label these specifically in terms of what their general identity is. What is sodium going to be? Sodium is going to be a cation. Okay, a cation. And what did we say a while ago that meant? That means it's going to have a positive charge. Okay. Now, the positive charge can vary depending on which element you're actually looking at. Oxide, therefore, is what? It's an anion. Okay, so these are both anions. Only distinction is one's a cation because it's positive, the other's an anion because it's negative. Now, sodium and oxide, what are their actual charges? Sodium, by virtue of being over here on the left in group 1A, okay, is going to be positive 1. So what I'm going to do is I'm going to write the symbol for sodium and I'm going to put a plus there. Okay? Sodium is positive 1. So that's the symbol for that particular cation. Oxygen, on the other hand, remember what I said a few seconds ago? These are 0, -1, -2. Okay, -2. All right? And that allows us to go ahead and say with conviction that O is 2 minus. Now, if you look at those charges and you add them up, do they total 0? No, they don't. So you have to figure out a formula that's going to allow them to total 0. In order to do this, we're going to need 2 sodium cations, right? And to go with that what? That 1 oxide I'm sorry, didn't mean to do that, with that 1 oxide anion. So what are we doing here? We're simply adding all these up. Positive 1 plus positive 1 plus -2. You add them all up. You add them all up. What do you get? You get 0. Now, the fact that you have 2 sodiums, okay, there's 2 sodiums and 1 oxygen, means that you write the symbol, okay? You place the number of sodiums as a subscript, and since there's only 1 oxygen, you don't have to put a 1 there. It's understood there's 1. You could put a 1. It doesn't change anything, but it's not necessary. So when you write representations of ionic compounds, you don't show the charges. You simply write it like that. So this is the name of sodium. This is sodium oxide. Okay, and so that here's our answer: Na2O. Na2O. All right. Now it's not disodium oxide. Okay. When you use the word di, tri, all that kind of thing, you're not talking about ionic compounds. You're talking about covalent compounds to do that. So this is sodium oxide. Okay, moving right along. We're almost done. Let me go now with you to question number 27 from your homework assignment number 2. Question number 27. It says calcium phosphate is a very common ionic compound. Okay, I've given you a clue there. It's going to be composed of ions, which is used in a variety of applications. Calcium phosphate. It is composed of the calcium cation, and I gave you the formula. There it is. And the phosphate anion. Now, let me say one thing about that before I move on. Folks, this is something that we call a polyatomic ion. All right, polyatomic ion. Now, you could call it a polyatomic anion if you want, but it's still an ion. Now, the reason it's called polyatomic is because it's composed of more than one atom. How do we know that? Well, there's a phosphorus atom there, and what else? There's 4 oxygen atoms, so there's more than one atom involved in this ion, so it's called polyatomic. But the overall charge on this polyatomic ion is 3 minus. Okay? And you've already been told that calcium, and we figured this out a while ago, has a charge of 2 plus. So you've got to figure out a ratio, okay, in order to make these add up to 0. Okay? So let me show you how to go about doing that. Now there's more than one approach. Maybe you watch the videos from YouTube inserts that I have here for module number 2 or unit number 2. But let me just show you a strategy that can be effective for you. One thing you can do, folks, is simply write down the ions like that, Ca2+. There's one, and then we're going to move over here and write PO4 3-. Okay. Now, if you can see instinctively what's needed here, great. But if you can't, let me show you kind of a trick, and this is only a trick. You see this 3 here? Right? Ignore the sign for the moment. See the 3? What I'm going to do is I'm going to drop that 3. The 3 is a number down here, okay? See that? Okay. Now, see this 2? See that 2? I'm going to take that 2 and drop it down here. And get 2. Why is that? It's really pretty simple. Why? Because 3 times positive 2? What's 3 times positive 2? Positive 6. What's 2 times negative 3? Negative 6. When you add up positive 6 and negative 6, what do you get? You get 0. So folks, this is a way to figure out how to write these formulas. So let me show you how to do that now. You already know, but let me show you anyway. Folks, we take the calcium, right? And how many did we say we needed? 3. Okay? 3. We need 3 of them. Now phosphate. Now phosphate's a polyatomic ion. And if there's more than one polyatomic ion in the formula, guess what you got to do? You got to put them in brackets. Okay? Because if you put it in brackets, that means that everything, okay, is going to get multiplied by the number that you place as a subscript. And what's that number? It's 2. Okay? So folks, that's how you do this. So our formula for calcium phosphate corresponds to which one of these? It looks like it's Ca. There it is. It's this bottom one. Okay? Now let me remind you again, folks. These are scrambled. Okay, these are scrambled on your OWL assignment. I'm sorry, on your Canvas assignment. So make sure that you bubble the right one. This is a good problem to look over. I want you to be able to do this on your first exam. All right, now let's go to the last problem I want to go over with you. Okay, this is number 30. Question number 30. It's the very last problem. This one always poses a challenge for students because they don't trust their instinct. But I want you to trust your instincts here, okay? When you solve a problem with this magnitude, you're going to find out it's really pretty straightforward. It said, which formula below corresponds to iron 3 oxide? Iron 3 oxide. Folks, ignore the answers, okay? Focus in instead, okay, on that. Look at that first. Ignore the answer. Now, what is iron 3? Is this a Roman numeral? Right? You've heard of Roman numerals. I'm sure you have. Folks, the Roman numeral is very important because it tells you the charge of cations. Not anions, but cations. Cations only. So if you see a Roman numeral 3 there, then you know the charge is 3+. Now, do you know the symbol for iron? In case you don't, you get out your periodic table. There it is. It's number 26, iron. And what's the symbol for iron? Fe. Okay, that's the symbol for iron. Now, what did we just say the charge was? It's positive 3 or 3+. Okay, iron 3 oxide. Now, think back to an earlier problem we did just a while ago. We were talking about oxygen because this is going to be this is going to come from oxygen, right? There should be no mystery there. We know it's O, right? But what's the charge on oxide? In case you've forgotten, you can figure that out by looking at the periodic table. Where's oxygen? Right there. So we're going to start here. It's going to be 0, -1, -2, -3. All right, so 0, -1, -2. So what does that mean? That means you can put a 2- here. So now you know the identity of what? You know the identity of the ions involved in this ionic species. Now let's do that little trick I showed you just a few seconds ago. I'm going to highlight this 2. Okay? And I know I'm going to put it down there. I'm going to highlight this 3. And similarly, I'm going to put it right there. What does that mean we can do? It means that you need what? 2 irons and how many oxygens? 3. So folks, this is iron 3 oxide. Some people look at that and they think, no, that's iron 2 oxide. No, it's not. This is iron 3 oxide. The reason it is because it has nothing to do with the subscripts. It has all to do with the charge. So it's Fe2O3. Fe2O3. This is B. There it is. It's B. B. Okay, guys, I hope this was useful in that you're able to understand how to solve those problems, and best of luck to you.